Hello everyone, and welcome to this video. Today, we'll be diving into the basics of semiconductors, the core building blocks of modern technology. You probably use phones and computers every day, but do you know how semiconductors play a role in these devices? Let's uncover their mysteries step by step. So, what is a semiconductor? Simply put, a semiconductor is a material whose electrical conductivity lies between that of a conductor and an insulator. Common semiconductor materials include silicon Si and germanium Ge. What makes semiconductors unique is that their conductivity can be adjusted by external factors like temperature or voltage. This makes semiconductors essential in all kinds of electronic devices. From computer chips to smartphones, nearly all modern tech relies on semiconductors. They control the flow of electricity and are fundamental in enabling electronic functions. So, how do semiconductors regulate electricity? In fact, semiconductor conductivity is influenced by environmental factors, especially temperature. When temperature increases, the conductivity of semiconductors also rises. This is in contrast to metals, whose conductivity decreases with higher temperature. Additionally, when voltage is applied to a semiconductor, its conductivity can change. For example, in a diode, when the voltage direction matches the semiconductor material, current flows smoothly, but when the voltage is reversed, current is blocked. In this way, semiconductors precisely control the flow of electricity, regulating signals in electronic devices. Why does the conductivity of semiconductors increase with temperature, while metals' conductivity decreases? The answer lies in the difference in the conductivity mechanisms of metals and semiconductors. In metals, as temperature increases, atomic vibrations intensify, hindering electron flow and reducing conductivity. However, in semiconductors, higher temperature causes more electrons to jump into the conduction band, creating free electrons and increasing conductivity. Now that we've covered the basics of semiconductors, let's see how they actually work. The role of a semiconductor in a circuit is like a valve, regulating the flow of electricity by controlling the movement of electrons. We can use an analogy to help explain this. Imagine the semiconductor as a water pipe, with the flow of water representing electric current. The valve is the semiconductor, which can control the flow of water by responding to changes in voltage. Voltage adjustments are like turning the valve to decide whether or not electrons can flow to semiconductors. A p-n junction is formed by combining p-type and n-type materials. P-type semiconductors have holes as charge carriers, while n-type semiconductors have free electrons. The p-n junction acts as a one-way valve, allowing current to flow in only one direction and blocking reverse current. This property is fundamental in diodes and transistors, enabling them to act as electronic switches and amplifiers. Why does a semiconductor act like a valve in controlling the flow of electricity? The answer is that semiconductors act like a valve because they control the flow of electrons in response to external voltage. When the voltage direction is correct, current can flow. When reversed, current is blocked. It's this ability to control current flow that makes semiconductors essential in switches and signal processing. Why are semiconductors so important? Semiconductor technology powers nearly every electronic device in our daily lives. Without semiconductors, modern technology wouldn't have developed to its current scale. Semiconductors are the key components in devices like computer chips, solar cells, and LED displays. They regulate the flow of electricity, enabling data processing, energy conversion, and signal transmission. From transistors to integrated circuits, advances in semiconductor technology have driven developments in information technology, communications, and energy efficiency. In short, semiconductors are the heart of modern technology, enabling us to enjoy faster, smarter devices.